Okay, problem number 6. We are looking for an angle first, in which the cosine of the angle is 1/3. That would be an angle in the first quadrant. So 1 right there, 3 right there, because the angle, cosine of the angle, is going to be the adjacent leg over the hypotenuse. And so we have to figure out the length of the opposite leg. So 1 squared plus, I always like b, so a squared plus b squared equals c squared, and 3 squared there. So 1 plus b squared equals 9, and if we subtract 1 from both sides, we're subtracting 1 from 9 on the right, so 9 minus 1 is 8. And if you take the square root of both sides, you're going to get b equals, again, we don't have plus or minus now because we're dealing with the length of a side. So the square root of 8 can be rewritten as 2 radical 2. So 2 radical 2 is the length of that leg. So the tangent of the angle, let's put it down here. The tangent of the angle is equal to the opposite leg over the adjacent leg, and so 2 radical 2 over 1 can be written as just 2 radical 2. All right. Now on to the to the equations. Now I want to just pause for a second here. I still keep getting the question, like, why 0 to 2 pi here, and why are we limiting the values of the inverse functions or the inverse expressions over here? Well, over here we're trying to find all the values of theta on the interval from 0 to 2 pi that make the equation true. So there's no inverse, there's no limited domains, there's no restricted domains, and therefore restricting ranges and things like that. So although kind of similar, they are different in the respect that when we're dealing with inverse expressions or inverse trig functions, we're dealing with a limited, there's only one angle that they can be, okay? And then again, just try to work that out, that understanding that when you solve an equation, you're not limited to a certain, well, on one hand we are limited from 0 to 2 pi here, but we're not limited to just one number, okay, or one angle. All right, so hopefully you've worked that out, and that's not too big of an issue, or it's not an issue at all, hopefully. So just kind of like a typical equation. If it's an algebraic equation, two-step equation like this that you saw back in pre-algebra or algebra 1, and you would just subtract 3 from both sides, which is exactly what we do here. So whenever we're solving a trig equation, or really any other equation that has a variable, which is every equation, but we always want to try to isolate. Typically, we want to isolate the expression that contains the variable. It's always special cases to that, but in general, we're isolating. That's why we move the 3 to the other side. So we have 2 cosine theta is equal to -1, and then dividing both sides by 2. I can show it. So dividing both sides by 2, the 2's cancel. Now we get the cosine by itself. We are not limited to only one number here. So we're trying to figure out the angle that the cosine is equal to -1/2. Well, around the unit circle, the cosine is -1/2 in the second and the third quadrants, and probably be helpful to draw a new unit circle. And so whenever I'm trying to figure out angles, I find it helpful to have something visual to look at here and visualize where those angles are. So the cosine, remember, is the x-coordinate. So we go over 1/2 and we go up to here. So -1/2, and we go up to this angle. And that angle is 2 pi over 3. So theta is equal to 2 pi over 3, as well as over 1/2 to the left and down to this angle. And that angle is 4 pi over 3. Now we're almost the 5-minute mark. We'll start a new video.